Welcome back, everybody, for another deep dive. And today we're going to be looking at ionic conductors.
Okay.
Which sounds super technical, right?
Yeah.
But actually, it's really interesting. And I think what's so cool about it is, like we were just saying, these are really the heart of fuel cells. And when I was reading through your notes about them, you were talking about how they're so crucial for the safety and efficiency of fuel cells.
Right.
And that material science plays a huge role.
Absolutely. Yeah.
And I thought, well, is this the key?
Well,
Are these the key to a sustainable future?
potentially they very well could be.
Okay.
To really understand why ionic conductors are so important, we kind of have to take a step back and think about how fuel cells work.
Okay.
They basically use a chemical reaction to generate electricity,
Oh, yeah.
combining hydrogen and oxygen, and the only byproduct is water.
So it's like clean energy
Clean energy.
in the truest sense.
Yeah.
No harmful emissions at all.
That's the idea.
Wow.
Yeah, so that's why they're so attractive as a potential energy source.
And you were saying that this could be revolutionary for things like transportation.
Oh, absolutely.
Grid storage.
Think about cars
Yeah.
running on hydrogen emitting only water vapor.
Okay.
Or imagine a power grid that's stabilized by fuel cells, seamlessly integrating renewable energy sources.
Yeah, that's a future I would love to live in.
Absolutely, it's a game changer.
Yeah. Yeah, okay, so how do these ionic conductors fit into all this?
So they're kind of the unsung heroes.
Okay.
Inside the fuel cell, they allow charged particles called ions to move around.
Okay.
And this movement is essential for the chemical reactions that generate electricity.
Got it.
You can think of them like tiny highways,
Okay.
designed specifically for these charged particles.
So no ionic conductors.
No fuel cell magic.
No fuel cell magic. Wow.
Yeah, and it gets even more interesting when we talk about the types of ionic conductors.
Okay.
So we have liquid electrolytes,
Uh-huh.
which are commonly used,
Right.
but they have some drawbacks.
Okay. Like what?
Things like flammability and potential leaks.
So safety becomes an issue.
Exactly.
Right.
So the alternative is solid electrolytes,
Okay.
which are safer, more durable.
Got it.
And that's where a lot of the cutting-edge research is focused right now.
And you mentioned material innovations being key to achieving high ionic conductivity.
Yeah,
So it sounds like scientists are on this quest
they are.
to find the perfect material
Precisely.
for this.
They're experimenting with a variety of materials from ceramics and polymers to even crystals.
Wow.
The goal is to find materials that allow ions to move as quickly and efficiently as possible.
So it's like finding the Autobahn
Exactly.
of ionic conductors.
Yes.
One that just allows for lightning fast travel.
Mm-hmm.
But why is this speed so crucial?
Because the faster the ions move, the more efficient the fuel cell becomes.
Okay.
And this translates to better performance and ultimately a more powerful and practical energy source.
That makes sense. But what are some of the specific challenges
Sure.
that researchers are facing in finding these super efficient materials?
Well, one of the biggest hurdles is finding a material that can maintain high ionic conductivity at a wide range of temperatures.
So it's not just about speed, it's also about resilience
Yes.
and adaptability.
Exactly. And that's just one piece of the puzzle.
Okay.
Researchers are also looking at the durability of these materials, how they interact with other components of the fuel cell, and of course the cost of production.
So it sounds like creating this ideal ionic conductor is a huge balancing act.
It is.
You're juggling performance and durability,
Yeah,
practicality and cost.
you got it.
Okay.
It's a complex challenge, but the potential rewards are enormous. Just imagine a world where we could power entire cities with clean, efficient energy
Wow.
generated by fuel cells. That's the vision
Yeah.
driving this research.
It's a pretty compelling vision.
It is.
But it sounds like there's a lot of work to be done.
Yeah,
Before we get there, what are some of the most promising avenues
sure.
of research in this field?
One area that's really exciting is the development of solid-state batteries.
Okay.
These batteries utilize solid electrolytes instead of the traditional liquid ones.
So it's the same principle as solid electrolytes
Exactly.
in fuel cells just applied to batteries.
Exactly, and the benefits are very similar.
Okay.
Solid-state batteries are potentially safer, more energy-dense, and could have longer lifespans than their liquid counterparts.
That sounds like a huge win
It is.
for electric vehicles.
Absolutely.
No more worries about battery fires?
Right.
Or limited range?
Exactly, and it's not just about electric cars.
Okay.
Solid-state batteries could revolutionize portable electronics grid storage and even medical devices.
So these tiny ionic conductors are impacting a wide range of fields.
They are.
Are there specific materials that researchers are focusing on for these solid-state batteries?
There are a few frontrunners.
Okay.
One is a class of materials called perovskites.
Perovskites?
Yes.
That sounds familiar. Aren't those also used in solar panels?
You're absolutely right. Perovskites are incredibly versatile materials.
Wow.
They're being explored for applications in solar cells, LEDs, and even thermoelectric devices.
It's like this multi-talented material
Yes.
that's making waves across different
Yeah,
scientific disciplines.
precisely. And that's part of what makes materials science so fascinating.
Yeah.
The discovery of a new material or a new property can have ripple effects across numerous fields.
It's like opening a door to a whole new world of possibilities.
It is.
But let's get back to ionic conductors and fuel cells. You mentioned earlier that finding materials with high ionic conductivity is key.
Right.
Are there other factors researchers need to consider?
Absolutely. Stability is crucial.
Okay.
The material needs to be able to withstand the harsh conditions inside a fuel cell, which involves high temperatures and corrosive environments.
So it's not just about speed,
Right.
it's also about resilience
Yes.
and toughness.
Exactly. And then there's compatibility.
Okay.
The ionic conductor needs to play well with other components of the fuel cell, like the electrodes and the catalyst.
It sounds like there's this delicate interplay
There is.
between all these different elements. It's like a complex orchestra where each instrument
Yes.
needs to be in harmony.
That's a great analogy. And just like an orchestra needs a conductor,
Uh-huh.
fuel cells need efficient ionic conductors to orchestrate the flow of energy.
So what does the future hold for this field? Are we on the cusp of a fuel cell revolution?
I believe the pace of research is accelerating and new breakthroughs are happening all the time.
Okay.
We're seeing significant advancements in materials, science manufacturing techniques, and our understanding of the fundamental principles
Yeah.
governing ionic productivity.
That's exciting to hear, but what about the practical challenges?
Sure.
Things like cost and scalability.
Those are valid concerns. Fuel cells are currently more expensive than traditional combustion engines.
Right.
And scaling up production to meet global energy demands is a huge undertaking.
So there are hurdles to overcome.
Yeah.
But the potential benefits are massive? It sounds like a classic case of scientific innovation pushing the boundaries of what's possible.
Exactly. And as with any groundbreaking technology, there will be challenges along the way.
Yeah.
But the pursuit of clean, sustainable energy is a goal worth striving for.
It's a goal that could quite literally reshape our world.
It could.
But I'm curious, are there any specific examples of how these advancements in ionic conductors are already making a difference?
Absolutely. One area where we're seeing significant progress is in the development of portable fuel cells. Absolutely. One area is portable fuel cells.
Okay.
These compact devices can power anything from laptops and smartphones to drones and even medical implants.
Oh, wow. So we're talking about like ditching the bulky batteries
Yeah,
and plugging in our devices to tiny fuel cells.
exactly.
That sounds like a game changer,
It is.
especially for things like drones where weight and battery life
Right.
are major limitations.
Absolutely. And with the advancements in solid electrolytes, these portable fuel cells are becoming even safer and more durable.
So these ionic conductors are really shrinking the
Yeah.
technology down to a whole new level.
Mm-hmm.
What about larger scale applications?
Sure.
Are there examples of fuel cells already making an impact in industries like transportation or power generation?
Yeah, several countries are already testing fuel cell buses and trains,
Okay.
and some companies are developing fuel cell powered trucks
Wow.
for long haul transportation.
So it's not just a futuristic concept anymore. These fuel cells are actually hitting the road.
They are.
That's pretty exciting.
It is. And in terms of power generation, fuel cells are being used as backup power systems
Okay.
for hospitals and data centers,
Interesting.
providing a reliable and clean energy source in case of grid outages.
So it sounds like these ionic conductors are really paving the way
They are.
for a cleaner, more sustainable energy future from our smartphones to our cities.
Mhm.
It makes you wonder what other applications are just around the corner.
The possibilities are truly vast. I think as research progresses and we unlock the full potential of ionic conductors, we could see fuel cells playing an even more prominent role in our lives,
Yeah.
powering everything from our homes and our cars to our industries.
It's incredible to think that something so small,
I know.
these tiny ionic conductors, could have such a massive impact
It is.
on our world.
It's a testament to the power of scientific inquiry and the incredible potential of materials science.
Well, this deep dive has been a real eye-opener. I've learned so much about these tiny but mighty ionic conductors and their role in shaping a cleaner energy future. I'm definitely going to be keeping an eye on this field.
It's been a pleasure exploring this with you, and to our listeners, I encourage you to dive deeper into the world of ionic conductors and fuel cells. There's so much information out there, and who knows, maybe you'll be inspired to join the quest for a more sustainable future.
Until next time, keep exploring.